Hello, this is E542 Lab Assignment 1 by Kaishyapi Umritwala. Object of the lab is to create a client-server model and communication between client and server using different types of sockets. So we'll create this network in this lab. Here, there are three VMs, client, router, and server. There is internal network named Net A between client and router and Net B between router and server. And all of those three VMs are connected to host PC using NAT adapter. So setup for the client server model, I installed Oracle VirtualBox 6.1.12, then installed Linux Ubuntu 18.04.5 image on VirtualBox. I cloned three VMs as client, router, and server. You can see that in this diagram, I allotted 1024 MB to each VM and two processors. I have 8 GB RAM in my host PC. I connected all VM with my host PC using NAT adapter and each other using internal network adapter. In the picture, you can see that Ubuntu clone client has adapter 1 as NAT and adapter 2 as internal network named NAT-A. I set host port and guest port for each VM. I allotted different host port number to each VM and same guest port 22 to each VM. First, I used Quagga to assign static IP addresses, network addresses, and default gateways to client and server. And I also set up the router by assigning it different network addresses and interface addresses. I replaced Quagga with Vyos router. Since Quagga do not support for DHCP, whereas Vyos router can assign IP addresses dynamically to client and server. So I installed Vyos 1.1.8 in VirtualBox and set up one NAT adapter and two internal network adapters same as before. So I have set up two interfaces of the router with different network addresses and DHCP servers, one client side and one server side. You can see the commands in the picture. First, I have set up the DHCP server shared network name main subset for one interface of the router. Then I'll set default router and set the pool of the IP addresses given by that subnet and default DNS server. I have done same for the other interface of the router. This is the final Ethernet interface setting of the VYOS router and DHCP server leases by client and server. Here we can see that there are three interfaces of VYOS router. One is Ethernet 0, which is connected to host PC. The other two are two interfaces connected to client and server. We can see that there are two leases of IP addresses of server and client. Here we can see 192.168.222.10 is server IP address and 192.168.220.10 is client IP address. So this is a script of server in Quagga. Here I have set inet to static and assign IP address of the server with the net mask. And I've also assigned default gateway for that server. I replaced Quagga script in both server and client by following. I set it to dynamic IP assignment since now we are using VYOS router which can assign IP dynamically. So we can see here that inet is DHCP. So when a socket is created, the program has to specify the address domain and the socket type. So two processes can communicate with each other only if their sockets are of the same type and in the same domain. There are two widely used address domains: Unix domain, in which two processes which share a common file system communicate, and the internet domain, in which two processes running on any two hosts on the internet communicate. The address of a socket in the internet domain consists of IP address. In addition, each socket needs a port number on that host. So port numbers are 16-bit unsigned integers. There are two widely used socket types in internet domain sockets. One is stream sockets, which use TCP, which is a reliable stream-oriented protocol, and the other is datagram sockets, which use UDP, which is unreliable and message-oriented. And the Unix domain sockets. It is the only difference between a socket in the Unix domain and a socket in the internet domain is the form of address. Unix domain has file system path as the address, so both client and server must be running on the same file system, and socket will remain until it is explicitly deleted. So this is the flowchart of the stream socket client server model. Here, the socket system call creates a new socket on both server and client side. It takes three arguments. The first is address domain of the socket. We use af underscore inet for it. The second argument is the type of socket. It can be datagram or it can be stream. The third argument is the protocol. It can be TCP or UDP. The bind system call binds a socket to an address of the current host and the port number on which the server will run. Now the server will listen on the socket for connections. The client sends connection request using connect function. The accept system call causes the process to block until a client connects to the server. Now, receive and send data after the connection get established. And when the connection needs to be terminated, we close the socket by calling close function on that socket. Here we can see that first we bind the server with 56010 port address. Now server is listening for the connections and now will connect the client to the server IP address and their port number, which is 192.168.222.10 and 56010, and will send the message to the server. Now here we can see that server has got the message, but we can also see that the server can handle only one connection at a time. So now capability of handling a number of simultaneous connections. After a connection is established, we can call fork to create a new process. Then we will close parent socket and execute the code for that specific child process. And the parent process will close the child socket and continue to listen for another connection. But this will create a zombie problem. A zombie is a process which has terminated but cannot die until its parent process called do wait or join on it. We cannot use the same PID of the child until it fully dies, and if child processes do not die, then it will clock up the process table in the kernel, and we will use sick child signal. So when a child dies, it sends a sick child signal to its parent. Now we can see I started a connection on port number 56101. So server has started and listening for the client request. Here I am connecting my client to the server on 192.168.222.10 and the port number. Now I can write the message that this is the stream socket. So now we can see server has got the message, and now still the server is on, so I can Again, open a new connection on that and write second connection. We can see that server has got the message. Now we will go to UDP socket. The UDP socket is similar to the TCP socket. Here we don't have listen, connect and accept function. But here, after a socket has been bound to an address, the program calls receive from to read a message, and UDP socket handles one connection at a time. This is a UDP server. We'll open a connection at server side. Now we'll go to the client and connect to the server on this particular port number. This is UDP socket. So the server has got the message and replied back that he has got the message. Now we'll go to the Unix domain socket. So we'll establish connection between two processes and communicate via socket. We'll write from the client and server will read it from that socket. So here process A can write data into socket X to be read by process B and can read the data that was written to socket Y by process B. We'll execute this into one VM because it needs to be the same file system. So I'm creating here my socket at server side. So it says that it is already in use, so we need to delete it first, but we can name it different. So we can see that the connection has already started. This is the client side. All right. This is the Unix domain socket. We can see that the server has got the message. So now designing servers. So first at concurrent connection oriented servers. It creates a stream socket and forks of a process to handle each new connection. It can transmit big amount of data. The examples are Telnet and FTP. Here we use TCP. While TCP is reliable protocol, so it has overhead of establishing connection. The second is iterative connectionless servers. It uses datagram sockets and it has much less overhead due to that, but the connection is unreliable. The last one is the single process concurrent servers. It has capability of handling server clients simultaneously. And when it is used when connection is IO dominated. The process manages several open connections and listens at each for a message. The select system call can be used for the same. So here I conclude my Lab1. Here we created client server model and successfully communicated between them using Vyos router with multiple simultaneous connections from the client by employing two methods, stream socket and datagram socket. We also established communication between two processes using Unix domain sockets.